Hello YouTubers and fellow hams. Well, I have a little product review for you. It's a little different, interesting little devices. So the company's name is Evo in Motion, or EIM technology. And what they are is, they are a company that makes simple, small, extremely portable electronic test equipment and tools for educational purposes and students. And I'm always interested in test equipment, aren't we all? Any of us electronics hobbyists. And they reached out to me and said that they wanted to send me a couple of their products for me to review. They were interested in the input from electronics hobbyists and creators and such. Their mission statement, according to Daniel, the representative that contacted me, Evo in Motion Technology is an ed tech company based in British Columbia, Canada, with the goal of making electronics learning more accessible for all. Their flagship platform, Lab on the Go, is something new that they're doing. This is a startup, as I understand it, and these are some of their first and earliest products. So he sent me a couple of the products to look at. A small power supply, which is really interesting in its form factor, and a tiny pocket multifunction test tool, which is a very small device that is an oscilloscope, function generator, spectrum analyzer, PWM source, and voltage bias reference source, all in a tiny little package. Now, they even state in their manual or on their website that these are not, they use the word professional, but they are quick to clarify that these are not going to have all the functions and capabilities of a lab quality tabletop piece of equipment like a full-on oscilloscope. So I'm not expecting this to act like a full-on oscilloscope, but I am interested in seeing the functionality that they do provide. So let's go take a look at them, open up the boxes, and then we'll hook them up and play around with them a little bit. These are the two products that they sent me for review, EIM technology. The megoo portable power supply and the Zoolark, what do you call this guy? Circuit debugger in pocket is what they call it. It's a micro oscilloscope and function generator. So let's open these up and let's see what you get in the box. Okay. USB cable for charging. Oh, good. I wondered about this. All the connection wiring you would need to hook it up. So that header plugs into the side of the unit, and then these are female pin connectors. So I guess you could use those to plug into things on the circuit board. I'm surprised they didn't use male pins if you're going to go into a breadboard, but they're female. All right. And this is, these are all separated out. So you'd plug those into individual pins on the Zoolark, and you got alligator clips on the other end for hooking into circuitry. And there's a little pouch and a little instruction manual. Alright, in the pouch, we should have the unit. Yep, there it is. Ooh, look at that. Oh, little bird. There it is. This is an oscilloscope and function generator, and it is small. It is about 5 centimeters tall by 6 centimeters wide. Only about 10 centimeters or 1 centimeter thick. It has controls. Here's a shuttle control here, left and right, probably for making changes to adjustments. A couple of push buttons there, push button here, USB-C port for charging. These are the headers over here and what they are. +5, -5, 3.3 volt supplies, a PWM output, wave output I suppose, DC, channel 1 and channel 2, and then these are all ground. And let's, I think that's the power switch. Yep. Wow. Alright, that's oscilloscope mode. And it's got 2 channels. Up here is the voltage per graticule segment, and over here is the time per graticule segment. Right now it's 1 ms, millisecond, and 1 volt for each of these. And I don't know if you can see that. This is what I need to use to look at this little bitty screen. But it's in oscilloscope mode by default, so these are probably menu buttons here. Oh, that changes. Oh, spectrum. Okay, that's spectrum analysis. 2 volt, 250 kilohertz. Okay, so this button lets you highlight what you're going to change, and then the shuttle will change it. Spectrum display up to 2.5 megahertz. Yep, that's the maximum. 1 megahertz, 500 kilohertz, 250 kilohertz, 100 kilohertz, 50 kilohertz, 10, 5, 1 kilohertz, 500 hertz is the lowest. So then I would guess you would hit the button to, okay, now the 2 volt highlighted there. See? And I can change the sensitivity, 5 volt per division, 18 or 10 volt per division to 1 volt per division, 500 millivolt per division is the minimum. So that's spectrum mode. And there's the function generator, where you can choose sine, square, triangle wave, amplitude, frequency, and DC offset. And PWM signal will output a pulse wave modulated signal of 3.3 volt. And you've got frequency and duty cycle. DC bias, I guess, is for adjusting these output biases. And then we're back to oscilloscope. So that's neat. Boy, that screen is tiny though. The screen is diagonally 4 centimeters. 2.8 centimeters wide and almost 3 centimeters tall. So yeah, tiny screen. So we're going to hook up this to a circuit in a minute, and we're going to check it out and see how well it works. But that's nifty. And this would be the power switch, so I'll hit that and that should shut it off. Yep. So that's the Zoolark micro oscilloscope. Function generator, PWM source, nifty little piece of test gear, and pretty small. You could probably tuck this away in a compartment in your electronics, your portable electronics kit. So I'm going to put this back in the pouch, and then we'll take a quick look at the Amigo power supply. What's in the box? Again, USB charging cable to micro USB. Manual, power supply, a USB to barrel coax connector, and a USB to alligator clip, and 3 tiny screwdrivers. I know what those are for. I've already peeked. So here it is, the Amigo portable power supply. Right now it's putting out 4.19 volts. Let's adjust that up to 5. This is what the screwdrivers are for, because the voltage adjustment is right here on the side, 4 to 24 volts, and you need a screwdriver to make that adjustment. So let's get that up to 5, shall we? Oh, it's a multi-turn pot. Okay. I already gave them a little feedback on this. I think that that's probably not the best. They should have a knob sticking out of the side or some kind of a digital adjustment. But let's get that to 5 volts. There we go. I think that's why they give you 3 screwdrivers, because you're probably going to lose one of these. Now, I'm going to turn it off for a minute because I want to show you something neat. So here's the output. And that is the full voltage range, and it says here set to 5 volt for cell phones. So if you're going to use this to charge your cell phone, you want to set that to 5 volts, 5 watt max. But look at this cutout here. You know what that's for? Well, I've got a classic breadboard here. I've had this one for years and years, and look at this. Oh, look at that. That doesn't fit. This breadboard I've had for 20 some years, so apparently this is made for different modern breadboards. The theory is that these are the output pins here, and this should plug onto your breadboard. So I'm not going to be able to use it with my old classic breadboard. Let me go grab the breadboard out of my AT Mega experimenter kit. I'll be right back. Okay, so this is an Amigo breadboard. Probably a more common standard. Yeah, I can already see the difference. Type of breadboard. And I'll bet you this plugs right onto here. Yep, look at that. It lines right up. So the pins line up, so the idea is that you plug this onto your breadboard, like so, and now your power is down the rails right off the bat. And you can then start breadboarding your circuit, and you've got your 5 volts or whatever your voltage is set to right there on the rails. Feature request or feature suggestion that I just thought of. Yeah, it's okay. Ooh, that's backwards. What? So I'm looking at this, and on this Amigo breadboard, they've got the red line on the outside, the blue line on the inside, so positive, negative, and on the end, it's positive, negative. But if we look here on the power supply, positive is on the inner one, and negative is on the outer one. And I don't know if those are reversible or not. But that's backwards from the way that this Amigo breadboard is color-coded. So EIM Tech is a startup. Maybe they sell their own breadboards, but pay attention to that. I think these slide off. Oh, they're stuck on with the sticker. So I'd have to... Do they slide off? I don't know. Oh no, they're just held on with the sticker. I'd have to reverse these, I think. Oh no, okay. Duh, silly me. Pay attention to this, guys. If you put it on this end of the breadboard, those power rails are backwards. So if I turn the breadboard around, now plus and minus line up. So that could be a gotcha. Yeah, pay attention to that. There we go. Now the plus lines up with the red rail and the minus lines up with the blue rail. So that's something to think about. But yeah, boom, just like that. My breadboard now has a portable power supply. I like this. This is a neat design. I really dig that. And then, of course, you can plug in the alligator clip lead here to the output on this USB port and have your voltage out like that. So that's really neat. And you know what? If I had this when I was developing the CW Vox, if I had this and I had the Zoolark, I would definitely have used these together to make the audio amplifier section of my CW Vox. And I probably would have used this to power the circuit, and except, oh yeah, I could have powered the circuit with this because I was using the regulator on the Arduino. Feature suggestion on the power supply. It might be useful if you had 2 independent voltages for each side of the rail. So you could put 5 volts on one side and 12 volts on the other side. If you were working with a circuit that used digital and analog electronics and you needed a 12 volt rail to supply the analog, I mean, you could always put a 5 volt regulator on your breadboard, use this to feed 12 volts to that, you know, and then get your 5 volts from there, but you'd have to make sure you didn't use the power rail because it would also have 12 volts on it on both sides. So it might be nice in a version 2 of this to have independent voltages on each rail. But boom, just like that, we've got 5 volts on the rails, and I could breadboard my circuit and I've got power with the portable power supply. So that's an overview of what these things are. Great for students, and I probably could have used it. For ham radio operators though, maybe not as useful for RF because this scope only goes up to 2 megahertz, I think. Or 2.5 megahertz. The specs will be up on the page, up on the screen. I'll put the web page up too. Well, let's build something and make it work. Okay, so I've breadboarded up a little circuit here. I've got an Arduino Nano, and I have a pot, And I've got a simple sketch I loaded in there that's going to do nothing more than generate a pulse width modulated output on D10, on pin 10, which I have hooked into channel 1 on the little Zoolark oscilloscope. So we're going to turn it on. There we go. And there's two traces, channel A and channel B. Channel A is yellow, I think, if it corresponds to the wire color anyway, channel 1 and 2. What I don't see is I don't see any way to adjust their position or to set a trigger level. So I'm assuming that's all automatic. So let's turn on the Arduino. Ooh, right away, there we go. Look at that. Can you see the pulse? Let me angle that so the light's not reflecting off of it. That's the pulse being generated by the Arduino, and if I rotate this pot, the pulse width should change. Look at that. Narrows, well, it's increased it. And there it's narrowing it down. Look at that. We can actually see the pulse width modulation changing as I rotate the pot. And see the pulses are getting narrower and narrower. And there they're getting bigger and bigger. Oh, it starts to lose trigger. So it's not doing a voltage trigger. If it was doing a voltage trigger, it would still lock those in, and I can't see any way to adjust the trigger. But there it sort of locks in when we get some separation to the pulse. And the display there, I'm going to try to zoom in on the video. This might not look so great, but it's showing a 5 volt max, 36 millivolt minimum, and a frequency of 500 and it's varying between about 501 and 509. Looks like it's centering around 506 hertz. So it's giving us the voltage of the pulse and the frequency. And we can visually see that pulse. Let me turn the pot again, see it widen and then narrow. That's pulse width modulation. But we lose the trigger when we get too narrow. See, there it's shifting. So it's not triggering on voltage, and I can't see how to adjust the trigger. That seems to be an issue, but it is working. I mean, it's an oscilloscope. Look at that. Ha! That is nifty. Okay, I've got my hand tech scope over here, so tomorrow morning, it's night, and I'm not feeling too great, but tomorrow morning I'll hook this up to my hand tech scope, and we'll take a look at the function generator, and we'll see what we can do with that. Okay, so we're going to try out the function generator. I've hooked up to the wave output, which is the third down on the top, with my scope probe. Let's turn it on. Okay, it comes up on oscilloscope. I will switch to function generator. Alright, sine wave, 2 volt, 1 kilohertz. So let me bring the trace speed down. Oh, that's looking like a sine wave. Okay, so there we go. So this is set to sine wave. There's square and triangle. I'm going to switch it to square. Look at that, square wave. Triangle wave. Well, it looks like a triangle wave. Now the Zoolark is telling me that it is set to amplitude of 2 volts, frequency of 1 kilohertz. And I know it's hard to see on the display, but that's reading 1 kilohertz, and peak to peak is reading 4.52 volts. This says amplitude is 2, so I guess they're just looking at a DC amplitude. Peak to peak is showing us twice that, 4.56. But it is a good triangle wave. Switch it back to square. Yeah, 1 kilohertz, 4.16 volt, peak to peak. So that's accurate. Well, this is still saying that I'm set to 2 volt amplitude. But I'm going to go back to sine wave. Good, okay. And then I'm going to, that's amplitude, frequency. The little highlight on the screen is changing as I press the middle button there, and it's at 1 kilohertz, so I'm going to increase the frequency. Well, it did increase 2 kilohertz, and it says it's a 2 kilohertz. Let's just keep going up. I'll increase the trace speed. There we go. Still got a nice clean sine wave. Let's switch waveforms. Okay, man, it's hard to keep this in shot and keep my hand out of there. I almost need 2 cameras for this. I'm going to... okay, our square wave's getting a little rounded off at 7 kilohertz. See it starting to round off there. Triangle wave still looks good. Let's increase the frequency some more. 8, 9 kilohertz. There's 50 kilohertz. We still got a good triangle wave. Let's see what that square wave looks like. Oops. There we go. You can see it highlight the waveforms at the top here, and I'm going to switch to square wave. Oh, it's really starting to look rounded off at 50 kilohertz. Our sine wave still looks good. What about voltage? Peak to peak, 4 volts, and the Zoolark is still set to amplitude of 2 volts. Let's keep going up in frequency. Oh wait, I'm going to switch it back to the square wave because that seems to be changing. So let's go back here, frequency. I can't get an angle here where I can keep my fingers out of the way. 70 kilohertz, 72, 80, 90, 100 kilohertz. Yeah, we're really starting to round off the attack. I mean, it still cuts off on the tail pretty good, but we're starting to round off at 100 kilohertz. 200 kilohertz, 300, 400 kilohertz. That would still trigger logic. Peak to peak voltages drop to 3.8, and I think they said in the manual that the waveforms tend to fall off at the higher frequencies, so they might still be working on that. But it is working as far as generating functions. Let's go back and see what the other waveforms look like. So so now the waveform's highlighted, and I'm going to switch it. Sine wave. Sine wave still looks pretty good. How's the triangle wave looking? Oh, yep, it's starting to get rounded off too. At 400 kilohertz. Let's go higher in frequency. Our triangle wave is starting to resemble a sine wave at 700 kilohertz, 800, 900. There's 1 megahertz. And that is supposed to be a triangle wave. Let's see what the square wave looks like. There's waveform selection. That should be a square wave. Yep, it's getting pretty rounded off. I mean, it would still trigger logic, but the timing would be a little late. That's alright. I mean, this is not a high quality piece of lab gear. This is for students playing around with electronics in their dorm room, you know. So for what it is, I mean, it is functional. It's generating well, at the higher frequency, 1 megahertz. Let's see how high we can go. Let's frequency. Okay, looks like that's the top. 1 megahertz is the top. Can't go any higher. Oh, I can't go back down. What? I can't go back down. Software bug, guys? I'm pushing back. I'm pushing down on the thing. It should be going down in frequency. But it's staying... Yeah, it's staying right at 1,000 kilohertz or 1 megahertz. Let me power cycle it. Function generator. Now we're back at 1 kilohertz. And there's our sine wave. I'm going to go to frequency and see if that's just the button that's bad. So we'll go up. Okay, there's 4 kilohertz. Oh no, I can still go down. We're at 39 kilohertz. Yeah, I can still go down. Okay, let's keep going up. There's 300 kilohertz. Yeah, I can still go down to 200. Okay. 400, 500, 600, 700, 800. I can still go down to 700. Okay. 900. I can still go back down to 800. 1 megahertz. And it doesn't go back down. I think they got a software bug there. If you get to 1 megahertz, it won't go any higher and it won't go back down. And I thought the specs said this might go to 200 or 2 megahertz, but it looks like it sticks on 1 megahertz. So, well, they are a startup, and I'm sure that they're continuing to work on the software, but that might be a software bug. But it does generate functions. That's supposed to be a square wave, and at 1 megahertz, that's a pretty rounded off square wave. And that's supposed to be a triangle wave. And yeah, it's rounding off that too at 1 megahertz. And I still can't go down in frequency. It's staying. So that might just be a software bug. I'm sure that they'll fix that in the future. But yeah, okay, function generator up to 1 megahertz. Cool. Okay, a few final thoughts on these. The power supply, I love it. The fact that it just mounts right against your breadboard like that and then provides power right on your breadboard rails, awesome. I will probably use this quite a bit whenever I'm breadboarding something. Adjustable from 4 to 24 volts and rechargeable. There's a USB-C port right here on the back where you charge it up. I don't know if they tell you what the capacity of the battery is on here. Capacity 7 watt hours. So for small electronic work, you could work for quite a while with that. 2 screws in the bottom, so the battery is it's serviceable, and it looks like it's held together with screws too. It's not glued together, so it might be serviceable. I'd imagine the battery's under there. The Zoolark little oscilloscope. Well, as we saw, it seems to be a software bug where it gets stuck at 1 megahertz when you're in the function generator or the PWM generator. But it does work. The waveforms kind of round off at the higher frequencies. I couldn't get above 1 megahertz. Those might be issues that they're aware of and they're working on. They are a startup. This is new stuff. I think this is their initial release. The input on this is this header here. And they give you this cable, breakout cable. But what I don't like about this cable, which doesn't make sense to me, is it has these female connectors. So you'd need a pin connector, like I'm using these little jumpers that have pin connectors, right? And you need that to plug into here in order to plug into a breadboard. It would seem to make more sense to me to have these pin connectors, yeah, there, you can see it there, with pins on there for plugging this directly into breadboard. They do, however, give you another cable with alligator clips on one end and female connectors on this end, so you can plug those in to the pins that you need as such, you know, plug in the ones you need and then just hook the alligator clips up to your circuit. So they do give you that for another connection option, and that's great. And then again, it is chargeable with a USB-C port on the side. I don't know about battery life. I didn't run it long enough to find out. I don't really have the stamina to do it right now. But it's a nifty little device. It has use, you know, it has use. If I was a student, electronics student, and I was experimenting in my dorm room, I would find this to be quite useful. You've got a spectrum analyzer, an oscilloscope, 2-channel oscilloscope. Although the oscilloscope should probably have at least the adjustments for setting the offset of the trace and a trigger. Although the automatic trigger did seem to work. There's a DC bias output as well. You can use this to provide a DC bias voltage into your circuit. So that's I suppose handy in certain cases. And then the oscilloscope, of course. Yeah, here the oscilloscope. Gives you a readout of frequency, voltage peak to peak of your waveform, and then a maximum. And up here we can set the divisions, the voltage per division, and the frequency, this 1 millisecond per division across. So yeah, there's some decent functionality there for such a small thing. I mean, this is tiny. There's my hand. This thing is tiny. So yeah, if I was an electronics student, I would definitely find this useful. A lot cheaper than buying a full bench scope, but of course you get much more functionality with a full bench scope. But then again, that's not what this target is. So I think it's well on its way to being a very useful bit of kit. Maybe a little refinement and maybe a few little bugs to fix. And I think it'll be quite a useful little thing. I think they're pretty neat. I think that they've got a nice idea. And thinking back to when I was in school at ITT Tech studying electronics, going for an EET, I would have loved to have had something like this at home. You know, being a student, I didn't have a big budget. I couldn't afford an oscilloscope, a real oscilloscope back then. I had to save up to get a multimeter, you know. So something like these would have been fantastic to have back then. I actually, thinking about it, I would have used the Zoolark in the design of my CW Fox when I was designing the amplifier stage. It would have been handy for the function generator to inject the an audio tone into it, and then the oscilloscope to measure the amplification through the stage as I was, you know, tweaking and fine-tuning it. I had to get my Handtech scope out, which living in the RV is a bit of a chore. I have to unpack it from where it's stored and then get it all set up on the desk, and it takes a lot of room on the desk. Whereas with that little Zoolark, I could have done what I needed to do with that device. It would have been adequate for me. And it certainly would have been far more convenient than getting out the big Handtech scope for the little project. I will probably have uses for it in the future, and I will probably be talking about it more in the future when I do use it for a project and showing how I use it for a project. I know you probably wanted a more in-depth dig into it, instead of just sort of an overview like I did, but well, that would make this video way too long, and it's probably already a bit too long anyway. So this is just more or less my quick glance at it, look at it, and presenting to you, you know, what they are. And the power supply I will probably use more often. That's just fantastic, the way it just snaps right on the breadboard, and then the power rails are active. You know, I don't have to get out my bench supply and run wires over to it, clip on with alligator leads. It just, there it is, and I've got power. I'll use that thing to death, I'm sure, when I'm breadboarding projects. So that's a great win. Well, that's it for this one. We'll see you in the next video. I think I'm going to build an antenna. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.